Today we're doing the second set of notes on graphing logs, and you'll be utilizing Desmos if you are at home. So if you are using the Desmos graphing calculator, the way you have to type this is log x divided by log b. So notice that the x is located here, and that will go first. The b is located at the base spot, and that will go second. The website again is Desmos graphing calculator. If you Google that, the website will show up. So for the first practice, or for the first example, it asks you to graph log base 2 of x. So again, the way you have to type this in the Desmos calculator is log x divided by log 2. The reason we have to do that is calculators are programmed to be base 10. So if the base is anything other than 10, we have to do this calculation called change of base. So I actually went to the website. So again, there's your graphing calculator. That's the way you will type it, and this is the picture that you would see. So go ahead and take a moment and plot these points on your paper. As far as some whole numbers, so 1, 0 is a nice point to plot. 2, 1 is a nice point to plot. 4, 2 is a good point to plot. And 8, 3 are some nice whole numbers. Notice this graph is leveling out at a vertical value, so my asymptote is going to be at x equals 0 for this problem. My domain is going to go from 0 to infinity because that asymptote will prevent the graph from going any further. The range is negative infinity to positive infinity because it will go forever down and the y values will go forever up. As far as the next statement, it wants you to find the change in y over change in x from 2 to 8, which is a fancy way of saying find the slope. So let me erase some of these dots here. When x is 2, the dot we're looking at is right there. And when x is 8, we're going here. So we need to find the change in y over change in x. Now, my graph has a whole bunch of more minor lines. Your graph will not. Again, you're just counting the rise over your run. And for here, this means I'm going up 2, and I'm going right by 6, which means positive 6, which means this will reduce to be 1 over 3. My x-intercept is where the graph crosses the x-axis. This will cross the x-axis right here, which means my x value is 1, and this will never cross the y-axis, so my y-intercept is NA. There's a problem located directly below this that I would like you to try on your own. It's log base 3 of x. On the next page, we have log base 3 of x plus 1. So notice I showed you how you'll be typing it in Desmos. Again, it'll be log of the quantity x plus 1 divided by log 3. In terms of some nice points that you can plot, 0, 0 is a very reasonable point to plot. 2, 1 is a very reasonable point to plot. And then you might have to, that one looks like 4 and a 1.75. So again, you should be able to kind of squeeze it on there. And my asymptote is happening right here. And we'll go through and answer the questions now. So my domain for this picture is from -1 to infinity. Now you might be thinking to yourself that that's at a -2, but remember, my graph is scaled, so this is -2, which means that right there is -1. My range is going from negative infinity to positive infinity. And the vertical asymptote this time where my graph is flattening out, so notice it's leveling out right there, it's getting straight, is at x equals -1. And the question says, how does it compare to the graph from number 2? This graph shifted left by 1. And the correlation there is because it says plus 1, that's why it shifted to the left one. So again, directly below it, you have a practice problem. Utilize Desmos to get your picture. In the homework, you're going to see a couple problems that look like this. The way you're going to type this in the calculator will be log of the quantity x plus 3 divided by log of 2, and then you're going to put the minus 1 on the outside. So you might have to use your cursor to move to the right to get that minus 1 on the outside. And then again, once you have that, then you'll just copy the graph from your website onto your paper.